Okay, so this video is about parametric integration. This function here, I want to find the shaded area, and the function is defined parametrically, or I've forgotten the range of values of t are between 0 and pi over 2. Now, one way we could do this is to convert this to Cartesian, and converting parametrics to Cartesian when trig is involved can be really fiddly. We don't need to do that. When we integrate normally, with a y equals function, we integrate the y equals bit with respect to x. Well, we haven't got this defined with respect to x, with respect to t, so I need some way of replacing dx with dt, and I need to put something here in terms of y. And it's really, really straightforward. All I do is I say, okay, y is equal to 5 sine 2t, so that just becomes 5 sine 2t. That's obviously not with respect to x, so I need to replace that. And to do that, I use the x equals equation. I differentiate it to get dx by dt. So that gives me 6 cos t multiplied by dt. So I can replace the dx with 6 cos t dt. So with parametric integration, you put the y equals function there, and you differentiate the x equals to get an expression for dx, like we did here. Right, let's simplify this. Let's pull the 30 out, that's a coefficient. And let's rewrite sine 2t. There's only one way of doing that, isn't there? Multiplied by another. So I've just replaced sine 2t with 2 sine t cos t. Got to pull the 2 out. And write that as sine t cos squared t dt. Now, we've just integrated that in the last video. If you didn't watch the last video, it's the one about when to use integration by parts. You can go back and watch that. I'm not going to go any further with that. The only thing we haven't done is work out the limits. Now, we know that t goes from 0 to pi over 2. Remember, this is an x-axis, so these aren't, that's not 0 and pi over 2, but the parameter is what we use to generate the x and the y values. Anyway, I'm not going to just assume that from t it goes from 0 to pi over 2. These 2 points here are when y equals 0. So I'm going to ask, when does that equal 0? So that's when does sine 2t equals 0. My range of values is that. So I need to go as far as pi for 2t. Here's the sine curve, and that's the bit I need to worry about, from 0 to pi. And 2t is 0 at 0 and pi. So t is 0 and pi over 2. So there we go, it was 0 and pi over 2, but it would have been wrong to assume that. So there we go. Anyway, look at the previous video if you don't know how to integrate that, and you should get 20 as your final answer.